We're going to look at finding tangent lines today and calculating velocity at a specific point. So let's start with reviewing what a tangent line is, what a secant line is, our slope formula, and how to find a line and point slope form. Alright, and so if we use our slope formula, then for our purposes today, we're going to be finding what's called instantaneous slope. And the formula for instantaneous slope is the limit as x approaches x1 of y2 minus y1 over x2 minus x1. So you're basically just finding your limit at a point of your slope formula. Okay, so if I look at example 1, I'm asked to find the tangent line to f of x equals x squared at the point 1, 1. So I'm going to use my instantaneous slope formula to find my slope, and then I can use my point slope form of a line to find the actual tangent line. So if I start with instantaneous slope, that would be the limit as x approaches x1 of y2 minus y1 over x2 minus x1. Okay, so I'm going to let this be x1, y1, because that's my point. And then I'm going to let x be x2, and my equation be y2. So if x1 is 1, then I'm going to find the limit as x approaches 1 of x squared minus 1, all divided by x minus 1. Your equation is always going to be your y2 when you're finding your instantaneous slope. And then x will always be your x2 when finding your instantaneous slope. Okay, and there's lots of ways we can find limits. One of them is direct substitution, but that doesn't work because 1 minus 1 is 0. So you'd get something undefined. Another easy way is to graph it. So we're going to graph this equation and then figure out what my limit is at that point. So I graph x squared minus 1, and I put that in parentheses, divided by x minus 1, put that in parentheses. And I graph it. I want to know what my x value, or what my y value is when x is 1. So if I go to 1, and I go up to approximately where my y value is, what is my y value at that point?
When you get to x.
Yep, if I go over to 1 and then I go up. Okay, but what is it close to? What y value is it close to if you just look at your graph? I go to 1 and I go up to where my line is, like 2. Okay, so then we know that my instantaneous slope is equal to 2. The second part of what I then would use is the point slope form of a line. So y minus y1 equals m times x minus x1. And our slope is m, and we know our x1, y1 from our point. So my equation would be y minus 1 equals 2 times x minus 1. And you can just leave it like this. You don't need to simplify it. Okay. So if you're given one point in an equation, that's how you do it. If you're given a table, it's a lot easier. So in example 2, I'm given a table of the charge of a battery over time. And so at 0, my charge is 100. At 0.02, my charge is 81.87. At 0.04, my charge is 67.03. 0.06, my battery is almost halfway dead. I'm at 54.88. At 0.08, I'm at 44.93. And at 0.10, I'm at 36.76. And since I want to know what my slope is at 0.04, I'm going to ignore all the numbers that don't have anything to do with 0.04. And I'm going to find my slope of this and my slope of this. And I'm going to average them. So if I start with what I circled in red, 0.02, 0.04. So if I let this be x1, y1, x2, y2, and I use my slope formula, well, y2 is 67.03 minus my y1, which is 81.87, divided by my x2, which is 0.04, minus my x1, which is 0.02. Okay, so what's 67.03 minus 81.87?
Negative 14.84.
14.84. Okay, and 0.04 minus 0.2.
0.0.
Okay, and so what's negative 14.84 divided by 0.02? Is that what it is?
It's negative 742.
Negative 742, okay. Okay, so I know my slope for the first part is negative 742. Now I want to find my slope for what I have in green. So I'm going to change this one to be x1, change this one to be y1, and x2, y2, and I'm going to do the same thing. So my y2 is 54.88 minus my y1, which is 67.03, divided by my x2, which is 0.06, minus my x1, which is 0.04. What's 54.88 minus 67.03?
Negative
And 0.06 minus 0.04.
0.02.
Okay. And so what does my slope then of what I've got in green become?
Negative 607.5.
Okay, so negative 607.5. So I know my instantaneous slope between 0.02 and 0.04 is going to be negative 742. My instantaneous slope between 0.04 and 0.06 is negative 607.5. So to find exactly where 0.04 is, we're just going to average these two numbers. So negative 742 plus negative 607.5, and we're going to divide that by 2. So what's negative 742 plus negative 607.5?
Negative 674.75.
Before you divide by 2. What's just the negative 742 plus the negative 607?
Negative 1,349.5.
Okay, so the top adds up to negative 1,349.5. And if you divide that by 2, what do you get, Mark?
Negative 674.5.
Very good. So my instantaneous slope is 0.04 is negative 674.75. That's it. So with a table, it's a lot easier than with a graph. Although, I mean, I guess the table's more work, but it's easier steps, I think. All right, and then the last part of what we're going to look at today is velocity, how to find your instantaneous velocity at some point. And velocity is just equal to your first derivative. And we found first derivatives last year, and we found first derivatives at the beginning of this year using our derivative formula. Okay, so our derivative formula is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Okay, so if I look at example 3, I'm asked to find the velocity at x equals 5 for the function 4.9 x squared. So the first thing I need to find is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So if I do that, then f of x plus h just tells me to put x plus h in for my x. F of x is just 4.9x squared. And that all stays divided by h. Alright, so if I simplify, x plus h squared is x squared plus 2xh plus h squared. And then everything else would stay the same. If I distribute my 4.9, I get 4.9 x squared plus 9.8 xh plus 4.9 h squared minus 4.9 x squared all divided by h. So it's kind of complicated, so let's simplify. So 4.9x squared and a minus 4.9x squared are going to cancel. So I'm left with 9.8xh plus 4.9 h squared divided by h. So we're going to take out an h. So 9.8x plus 4.9h tells me that my top and bottom h cancel. And if h is equal to 0, then my h connected to my 4.9 also cancels out this whole thing, because 4.9 times 0 is just 0. So all I'm left with in the end when I simplify is 9.8x. And so that's my first derivative of f of x. So if I want to find when x equals 5, then I just plug in 5 for x. So f prime of 5, my first derivative at 5, is 9.8 times 5, which is what? 49? So, which is equal to 49. So my velocity at x equals 5 of that graph is equal to 49. So you guys are going to work through page 49, 1 through 9.